Is time travel possible? Everyone has thought about time travel at least once in their life. Maybe you've wanted to go back in time and try to change something from your past. There's even a lot of science fiction movies out there that involve time travel, or were inspired by time travel in some way or another. But is it really possible to travel back or forward in time? And if it is really possible, what would we have to do in order to make time?
Woman looks like she's talking on the phone again. This sort of seems like something you see every day, someone just walking around the street and talking on the phone. But there's only one catch. The first cell phone was much bigger and not invented until the 1980s. The object that she's holding is difficult to determine, but as you take a closer look, it does seem to take some type of rectangular shape. What were these devices used for if it wasn't a phone? What does this woman know about time travel? Only she knows the true answer.
The very thought about time travel and what it would take to make it a reality is mind-boggling. It is something that scientists, especially astrophysicists, have long thought about. The most fantastic thing? It's probably possible. We should probably start off with the bad news about time travel. We probably can't travel back in time and watch the Egyptians build the pyramids. However, there are a number of theories that have suggested that it is possible to take a leap forward in time, but going back in time is far more complicated. That's not saying it's impossible, though. The great 20th century scientist Albert Einstein developed a theory called special relativity. While most people think of time as a constant, Einstein showed that time is an illusion. It is relative in that it can vary for different observers depending on your speed through space. The ideas of special relativity are very hard to imagine because they aren't about what we experience in everyday life. But other scientists have confirmed this theory. The theory says that space and time are really aspects of the same thing, which is called space-time. There is a speed limit of 300,000 kilometers per second, or 186,000 miles per second, for anything that travels through space-time. And light always travels this speed limit through empty space. So more about this illusion of time. Special relativity says that a surprising thing happens to you when you move through space-time, especially when your speed relative to other objects is close to the speed of light. Time goes slower for you than for the people you left behind. You won't notice this effect until you return to those stationary people. So as an experiment, let's say you were 15 years old and you left Earth in a spacecraft traveling at about close to the speed of light, and you celebrated only 5 birthdays during your space voyage. When you got home at the age of 20, you would find that all your classmates, who were the same age as you when you left, were 65 years old, retired, and hanging out with their grandchildren. The reason for this is because as time passed more slowly for you, you would have experienced only 5 years of life, while your classmates will have experienced a full 50 years. But there is something else under Einstein's theory of general relativity, and that is gravity can bend time. Picture a 4-dimensional fabric called space-time. When anything that has mass sits on that piece of fabric, it causes a dimple or a bending of space-time. The bending of space-time causes objects to move on a curved path, and that curvature of space is what we know as gravity. So how could we travel through space-time? One option would be a wormhole, also known as an Einstein-Rosen bridge. Along with physicist Nathan Rosen, Einstein suggested the existence of wormholes in 1935, and although we've yet to discover one, many scientists have contributed their own theories about how wormholes might work. Stephen Hawking and Kip Thorne are probably the most well-known. Thorne, a theoretical physicist at Caltech, even helped Christopher Nolan with the science behind Interstellar. So let's just assume that wormholes do exist. In the late 1980s, Thorne said that a wormhole could be made into a time machine. According to Einstein's theory of general relativity, a wormhole could act like a bridge through space-time by connecting 2 distant points with a shortcut. Certain types of wormholes, it's theorized, could allow for time travel in either direction if we could accelerate one mouth of the wormhole to near light speed and then reverse it back to its original position. Meanwhile, the other mouth would remain stationary. The result would be that the moving mouth would age less slowly than the stationary mouth thanks to the effect of time dilation. But wormholes are tricky. They create all kinds of paradoxes. For instance, through a wormhole, a person could see themselves as they were 1 minute ago. But what if that person used the wormhole to shoot his earlier self? They are now dead. So who fired the shot? It's a paradox. It just doesn't make sense. You might have seen some of this paradox stuff in a famous science fiction movie that had an interesting time machine. Bonus points for the viewer who can name the film. And back on the subject of time dilation, the clocks on the International Space Station tick just a little bit more slowly than clocks on Earth do. Since the space station is moving so fast and is affected by less gravity, time moves more quickly. It's also why no clock on Earth is perfectly accurate, since the effect of time dilation means that time moves more slowly closer to the planet's surface. You could say that everyone aboard the International Space Station is a time traveler. You can get a better understanding of how time dilation works by looking at GPS satellites. The GPS chip in your smartphone works because there are 24 satellites circling the globe at all times that triangulate your location based on how long it takes time-stamped information to travel to and from the device. However, scientists learned when building the system that the atomic clocks on GPS satellites do indeed run a little bit fast, since they are moving at 9,000 miles per hour in orbit. To be specific, they lose 8 microseconds a day. That's hardly perceivable, but it's enough to throw off the location data. And so, GPS technology makes adjustments to the clocks on board to account for the relativistic effects. The problem doesn't lie with the clocks. They run fast because time itself runs faster in space than it does down below. And the reason for this extraordinary effect is the mass of the Earth. Einstein realized that matter drags on time and slows it down like the slow part of a river. The heavier the object, the more it drags on time. And this startling reality is what opens the door to the possibility of time travel to the future. Right in the center of the Milky Way, 26,000 light-years from us, lies the heaviest object in the galaxy. It is a supermassive black hole containing the mass of 4 million suns crushed down into a single point by its own gravity. The closer you get to the black hole, the stronger the gravity. Get really close, and not even light can escape. A black hole like this one has a dramatic effect on time, slowing it down far more than anything else in the galaxy. That makes it a natural time machine. So, a supermassive black hole is a time machine. But of course, it's not exactly practical. It has advantages over wormholes in that it doesn't provoke paradoxes. Plus, it won't destroy itself in a flash of feedback. But it's pretty dangerous. It's a long way away, and it doesn't even take us very far into the future. Fortunately, there is another way to travel in time, and this represents our last and best hope of building a real time machine. You just have to travel very, very fast. Much faster even than the speed required to avoid being sucked into a black hole. This is due to another strange fact about the universe. There's a cosmic speed limit, 186,000 miles per second, also known as the speed of light. Nothing can exceed that speed. It's one of the best established principles in science. Believe it or not, traveling at near the speed of light transports you to the future. To explain why, let's dream up a science fiction transportation system. Imagine a track that goes right around the Earth, a track for a super-fast train. We're going to use this imaginary train to get as close as possible to the speed of light and see how it becomes a time machine. On board are passengers with a one-way ticket to the future. The train begins to accelerate, faster and faster. Soon, it's circling the Earth over and over again. To approach the speed of light means circling the Earth pretty fast, 7 times a second. But no matter how much power the train has, it can never quite reach the speed of light, since the laws of physics forbid it. Instead, let's say it gets close, just shy of that ultimate speed. Now, something extraordinary happens. Time starts flowing slowly on board relative to the rest of the world, just like near the black hole, only more so. Everything on the train is in slow motion. It really is that simple. If we want to travel into the future, we just need to go fast, really fast. The fastest manned vehicle in history was the Apollo 10. It reached 25,000 miles per hour. But to travel in time, we'll have to go more than 2,000 times faster. And to do that, we'd need a much bigger ship, a truly enormous machine. The ship would have to be big enough to carry a huge amount of fuel, enough to accelerate it to nearly the speed of light. With a ship the size we would need, getting to just beneath the cosmic speed limit would require 6 whole years at full power. While time travel does not appear possible at this point in time, or at least possible in the sense that the humans would survive it. With the physics that we use today, the field is constantly changing. Advances in quantum theories could perhaps provide some understanding of how to overcome time travel paradoxes. One possibility, although it would not necessarily lead to time travel, is solving the mystery of how certain particles can communicate instantaneously with each other faster than the speed